towers of height h1 and h2 subtend angles of 60 and 30 degrees respectively at the midpoints of the line joining their feet. Find h1 over h2. So AB is one tower and the CD represents the other tower. So ABCD represents the towers of height h1 and h2. The other thing they say is they make an angle of 60 and 30 respectively at the midpoints of their line joining their feet. So here is a line joining their feet. BD is a line joining their feet, and this is the midpoint. E is the midpoint. That is why you take BE as X and ED is also X. So we'll just write that. We have E is midpoint of BD, which means BE equal to ED equal to X meter. We'll now take up the first triangle ABE, triangle ABE, and we will use trigonometry there. So the perpendicular here, the angle is 60, and if the angle is 60, this is perpendicular and here is the base. So theta is 60, perpendicular AB, which is h1, and base is BE, which is X meter, and tan theta equal to perpendicular over base. So tan of 60, perpendicular AB, base BE. So tan 60 is root 3 equal to h1 over x. So root 3x equal to h1. To find h2, we now take up the triangle ECD. So triangle CDE. Here will be the perpendicular and this is the base. So theta 30, perpendicular is DC, which is h2 meters, and the base is ED, which is X meter. So we have tan theta is perpendicular over base, and tan 30 equal to perpendicular DC, base ED. So tan theta is 1 by root 3, DC is h2 over x. So h2 is x over under root 3. Next we need to find the ratio of h1 over h2. So h1 over h2. h1 is under root x over x over under root 3. So this x will cancel. Divide by 1 over under root, and this would be under root 3 into under root 3. So we have under root 3 divide by 1 under root 3 into under root 3. So that is 3 over 1. So the ratio of h1 over h2 is 3 over 1, or 3 ratio 1. Find the angle of elevation of the top of a 15-meter high tower at a point 15 meter away from the base of the tower. So here we have AB is the tower, and this tower is 15 meter high. So we'll write 15 meter. So AB is the tower which is 15 meter. Then a point 15 meter away, so the point is C and this point is 15 meter away. So here is 15 meter. So BC is a distance of the point from the tower, from foot of the tower. And BC equal to 15 meter. Now we need to find the angle of elevation. Now which is the angle of elevation? C is the angle of elevation. This is the horizontal, and here you have the line of sight. So C is the angle of elevation here. So when you see C, here is perpendicular and this is the base. So tan theta, we don't know what is tan theta, but we know perpendicular is AB, which is 15 meter, and the base is BC, which is also 15 meter. So tan theta is perpendicular over base. Here in the sum we don't know theta. Perpendicular AB, base BC, which is 15 over 15. So tan theta equal to 1. And we know from the table that tan 45 is equal to 1. So on comparing both these, I can say theta is 45. So angle of elevation is 45. The angle of elevation of the sun at a given time is 30 degrees. Then find the length of the shadow cast by the tower 150 meter height at that time. So here we have a tower, and this tower I will call as AB, and it is 150 meter high. Now the angle of elevation of the sun is 30, which means if the sun is here, if this is the sun, then the angle of elevation would be exactly this. This would be its angle of elevation here. Here this is the rays of the sun that would come, and the shadow of this tower would be here, this, say C. So let me write that. AB is a tower which is 150 meter, and BC is the shadow, which we don't know, we need to find, so we'll put it as X. So I repeat again, this is the shadow here of that tower, and the angle of elevation is 30. Angle of elevation is, this is the line of sight with the horizontal, so this is 30. So in the triangle, we will now take triangle ABC. Theta is 30. Perpendicular, here we have perpendicular, and this is base. Perpendicular AB, which is 150 meter. The base is BC, X meter. So we are going to do tan theta perpendicular over base. So tan of 30 perpendicular AB, base BC, tan 30, 1 by root 3, 150 over X. When you cross multiply, X equal to 150 root 3 feet. This is the length of the shadow. (150√3 feet). At some time of the day, the length of the shadow of a tower is equal to its height find the sun's altitude at that time. So here again we have a tower. So say tower is AB, the length is not given, but the shadow is equal to its height. We need to draw the shadow. To draw the shadow we always need the sun, and with the sun we are now going to draw the angle of, we are going to draw the shadow. To draw the shadow we have to, from the sun we have to draw the angle of elevation of the sun. So this is the sun's rays that are coming down, and here will be the shadow. This would be, just draw it a little thicker, this would be the shadow of this tower. So here is shadow, and this is the height of the tower. Now they are equal, so if height of the tower is h, the shadow is also h. So let me write that up. So we have AB. AB is tower, which is h. BC is shadow of the tower, which is also h as per the condition, and the angle of elevation, this is theta, the angle of elevation. Theta, angle of elevation. So here we have the perpendicular for theta. If this is theta, this will be perpendicular and this will be base. So we write now in triangle ABC, we don't know theta, that is our question. We have to know our perpendicular is AB and base BC, which is the shadow, is also h, and tan theta perpendicular over base. So tan theta is h over h. Tan theta is 1, and tan of 45 is equal to 1. So I can say theta equal to 45. Angle of elevation equal to 45. A man standing on the deck of a ship which is 10 meters above the water level. So let me draw that. So here is my water level, and the man is standing 10 meters above. So he's standing here 10 meters. We'll call this CD, above the water level. Here we have marked this 10 meters above the water level. Observes the angle of elevation of the top of a hill as 60 degrees. So we have the hill, we call the hill AB, and the angle of elevation of the top of the hill. So the horizontal with the line of sight. So this angle is 60 degrees. And the angle of depression of the base of the hill is 30. Now which is the base of the hill? Here is the base of the hill. This point B is the base of the hill. The point here A was top of the hill. Now the angle of depression from this point C is a point of observation. The angle of depression, they said, is 30. Now how do we draw angle of depression? First we draw the horizontal and then the line of sight. From here he is looking at the base of the hill. This angle is 30. So we have to find the height of the hill. The full AB we have to find. So again I'm just repeating it. The person is at C, and from C he is looking at the top of the hill. He is making an angle of 60. So here's the same diagram. We have DB was the C, and the man was 10 meters above at point C. So here we had CD, which was 10 meters, and from there he was looking at the hill. Here AB is the hill, AB, and from C he looked at the top of the hill. So here he was looking at the top of the hill and making an angle of elevation of 60. Then from the same point he was looking at the bottom of the hill here, and the angle of depression was 30 degrees. So first we'll take up the triangle with 60, that is triangle AEC. So I'll take up triangle ACE. The theta is 60. This is our theta, which is 60. Here is the perpendicular. This is the base. So we do perpendicular is AE, and which we don't know, and the base is also CE, which we don't know. So we cannot basically start from this triangle. We need to start from the other triangle. We need to start from the triangle 30, which means this is our triangle. So we'll have triangle BCE. Here is a perpendicular, and this is the base. So theta is 30, perpendicular BE. Now we see BE is equal to 10 meters because BE equal to CD. I just rewrite it here. So CD equal to BE equal to 10 meters, which is 10 meters. The base is CE, and we don't know it. So we start with 10 theta perpendicular over base. Here 10 30, perpendicular BE, base CE. So 1 by root 3 equal to BE is 10, CE we don't know. So CE is 10 root 3. So we know CE is 10 root 3, and I'm going to write here 10 root 3 because I found out that CE is 10 root 3. Now for this triangle again, 10 theta perpendicular over base. So we have 10 of 60 perpendicular AE, base CE. 10 60 root 3, AE we don't know, but CE we saw is 10 root 3. So root 3 into 10 root 3 equal to AE. So AE is 10 into 3, that is 30. Now we have to find the height. We need to find the height of the hill. So the height of the hill is AE plus BE. So height of hill, which is AB, it is made up of two parts, AE plus BE. So AE is 30 and BE we saw was 10. So the height of the hill is 40 meter. We also have to find the distance of the hill from the ship, and the distance of the hill from the ship is represented by dB, and we know dB is also equal to CE. So the distance between the hill and the ship is dB, and dB equal to CE, which is CE we found was 10 under root 3. We found it 10 under root 3. So 10 under root 3, 1.732, which is 17.32 meter. So that is the distance, 17.32 meter. The shadow of a flagstaff is 3 times as long as the shadow of the flagstaff when the sun's rays meet the ground at an angle of 60 degrees. Find the angle between the sun's rays and the ground at the time of the longer shadow. So here they're talking about a flagstaff, and the flagstaff, I will draw it as AB. This is the ground. And then they're talking about two shadows, one shadow being longer than the other. So the sun's position must be at two places. One would be this position, and when this is the position, we would get a shadow. We'll put it in different colors. So the shadow here would be the sun's rays. This would be one shadow. Yeah. And we'll mark that shadow as CB. And now the sun would go a little lower, and when the sun goes lower, the shadow gets longer. So in this case, now we'll have the shadow a little longer, and that would be here, right? So this would be the shadow in the next case, which is now BD. And they said one of the angle is 60. So this angle here, this angle is 60. Now let's just read the sum again. The shadow of a flagstaff is 3 times as long as the shadow when the sun's rays meet at 60. So when it is 60, when the angle of elevation is 60, the shadow is BC, which is X. So this is X. I'll put this here as X. Now the shadow, the angle of elevation is theta. We don't know the angle. So angle is, say, theta. We don't know. But for theta, the shadow we saw is BD is a shadow. And BD now is 3X. They said 3 times longer, which is equal to 3x. So right from here to here, this is 3x. We have to find the theta. We go to the figure again. So AB is our flagstaff, and we get two shadows. One when the sun is a little high up here, in this position, 60 degrees is quite high. And in this case, the shadow is BC, which we gave as X. And then the sun comes down. Here is the sun coming a little down, so the inclination is more here. And now in this case, the shadow is BD, this shadow, which is, they said, 3x. It's 3 times more, so it is 3x. We have to find the theta. So we now start with this triangle A, B, C. So in triangle A, B, C, the theta is given 60. Here is the perpendicular, and this is the base. So perpendicular AB, which we'll call as H, the height of the flagstaff. The base BC, which we'll say X, which is a shadow in this case. And we know 10, 30 is perpendicular over base. 10, 60, perpendicular AB, base BC. So root 3 equal to H over X. So I have now my H equal to root 3x. This is important. Now I go to the other triangle, and that triangle is ADBC. Yeah, that is triangle ABD. The theta we don't know, it's a question mark. This angle of elevation of the sun. Here perpendicular is the same. You will see in this perpendicular is, this is the perpendicular, and here is the base. So perpendicular is AB, which is H, and the base is BD, which is 3x. And why 3x? Because they said the shadow was 3 times longer. First the shadow was x, now the shadow is 3x. Tan theta perpendicular over base. Now remember, we do not know tan theta here. So tan theta is perpendicular is AB over BD. Tan theta AB is h, BC is 3x. But we found our x as root 3x here. So we have tan theta equal to, for x will be root 3x over 3x. So I'll just continue here. So tan theta xx cancels, root 3 over 3. This is root 3 over 3 is root 3 into root 3. So this cancels out. So tan theta 1 by root 3. If tan theta is 1 by root 3, we know also that tan of 30 is 1 by root 3. So I can say theta equal to 30. So this angle here is equal to 30 degrees, and that's the answer. This is 30. So in the sum, first using the triangle, here we took the blue triangle, and in this blue triangle we found h. And after the blue triangle, then we took the yellow triangle, and with the yellow triangle then we found theta. A man rowing a boat away from a lighthouse 150-meter high takes 2 minutes to change the angle of elevation of the top of the lighthouse from 45 degrees to 30 degrees. Find the speed of the boat. So here we have a lighthouse. We'll name the lighthouse as AB. And there is a boat that is sailing away from the lighthouse. So from the base of the lighthouse, it is moving away in this direction. Now at 2 positions, it looks at the top of the lighthouse. Say here at this position, it's we call this position, say C. When it reaches C, the boatman looks at the top of the lighthouse, so he makes angle of elevation. So from here, he is looking at the top of the lighthouse. So he's making an angle of elevation. First is 45. Then he sails even further. See, further he sails here. And then from this point again, he looks at the top of the lighthouse at the points, say D. Again, he's looking at the top of the lighthouse and is making an angle of elevation. This time the angle of elevation is 30. Another important point to note here is he takes 2 minutes to move from one point to another. So from C to D to move, the time he has taken is 2 minutes. We need to find the speed of the boat. Now whenever we want to find speed, we know speed equal to distance over time. The time we know, but what is the distance traveled in this 2 minutes is from C to D. This is the distance. So we need to find the CD. So the speed will be CD, which is a distance, over the time, that is 2 minutes. So in this sum, we need to find our CD. This distance from C to D. So here's a nature diagram. So AB is a lighthouse which is 150 meter, and the boat is at point C. From point C, he looks up here. He makes angle of elevation, which is 45 degrees. So we'll first take up this triangle. This is triangle ABC. The theta is 45. Here is perpendicular, and this is base. So we have perpendicular, which is AB, and it is 150 meter. The base is BC and we do not know. So we take tan theta is perpendicular over base. In this case, tan theta is tan 45. Perpendicular AB, base BC. So tan 45. Now AB we got 150, BC we do not know. So tan 45 is 150 over BC. So BC equal to 150. So we are done with one triangle. Now it's time to take the other triangle with 30 degrees. Now we take up triangle ABD, the triangle with angle 30 degrees, this triangle. So we have triangle ABD, this is point D, theta 30 degrees, perpendicular, this is perpendicular here, and this was base. Perpendicular AB, which is 150 meter, and the base is BD, which is not given to us. So we go ahead and find tan theta. Tan theta perpendicular over base. So tan of 30 in this case, perpendicular AB, base BD. Tan theta 1 over root 3. AB 150, this is BD. So you get your BD is 150 root 3. Now if you remember, we were to find the distance. We had to find the CD, this distance. And then we have to do distance over time to get speed. Now see the distance CD. Look up in the figure and see what is CD. CD is BD, that entire, minus BC. And BD we found is 150 root 3 here. And earlier we found BC is 150. So our CD is 150, open the bracket, root 3 minus 1. This is our CD, which is a distance. So now in time 2 minutes, the bow travels a distance CD, which we now have calculated as 150 root 3 minus 1. The time is 2 minutes. So distance equal to 150 root 3 minus 1. Time 2 minutes. It was given to us. It takes 2 minutes to travel that distance. So the speed equal to distance over time. That is 150 root 3 minus 1 over 2, which is 75 root 3 minus 1. And if the value of root 3 is given to you, then you put 1.732 minus 1, 75 into 0.732, and that is 54.9 meters per minute. The angle of elevation of the top of Q of a vertical tower PQ from a point X on the ground is 60 degrees. At a point Y 40 meters vertically above X, the angle of elevation is 45 degrees. Find the height of the tower PQ and the distance XQ. So first we have a tower PQ. So we have PQ, so I put P here and Q. Q is the top of the tower. From a point X on the ground is 60 degrees. So there is a point X on the ground here, and from this X I am watching the top of the tower. So I am looking at the top of the tower is here. So this angle of elevation is 60 degrees horizontal with the line of sight. It's 60 degrees. Then at a point Y, 40 meters vertically above X. So this is X and I must go vertically above X to this point Y here. The angle of elevation is 45. So from Y again I'm looking at the top of the tower. Now the angle is 45. So this is the horizontal. Here is my line of sight and the angle between them is 45. So this is 40 meter. We need to find the height of the tower. So we need to find PQ. Our question is to find this entire PQ and this distance PX or XQ we have to find. So not this, we have to find XQ. So here's a diagram. So we have PQ as a tower. Then from there we have a point X, and from X we are looking at the top of the tower. Here I'm making an angle of 60 degrees. And then we go up 40 meters up to a point Y. So this is 40 meter. And again we look at the top of the tower. And we make now an angle of 45. This angle is 45. So we need to find the height of the tower. PQ, we need to find the entire PQ, the height of the tower. So here's the figure. So first we will take the two angles, 145 and 160. So this is the triangle for 60. So we take up this triangle. That is, we'll take up triangle PQX. The angle is 60. Theta is 60. Here is a perpendicular. This is perpendicular. And this is the base. So let's write perpendicular PQ, which we will write as 40 plus X, or we just keep it as PQ. And then the base is PX. In this case we'll write it as X. Here we've taken this as H. QL is H, so this becomes 40 plus H. We do 10 theta perpendicular over base, that is 10 of 60. Perpendicular is PQ, base is PX. 10 60 is root 3. PQ 40 plus H over X. So here what I'm going to do, I'm going to find the value of X. So X is 40 plus H over root 3. Now we take up the next triangle, and this is my next triangle. Triangle QLY. Theta 45 here. Perpendicular QL, which we write as H, and base here, base is LY, which we'll write as X. Why X? Because we know LY is X, because we know PX equal to LY, which is X. See this line, these two are equal. So we do 10 theta perpendicular over base, and that is 10 of 45. Perpendicular QL, base is YL, so 1045 is 1, QL is H, YL is X, so we get X equal to H. Now we got two expressions of X. We got X here and we've got X here also, so we'll equate X equal to X, so 40 plus H over root 3 equal to H. Cross multiply, 40 equal to root 3H, so 40 equal to root 3H minus H, so 40 equal to H, common out root 3 minus 1. Therefore, H equal to 40 over root 3 minus 1. So 40 over root 3 minus 1 will rationalize, root 3 plus 1, and here root 3 plus 1 equal to H. So 40 root 3 plus 1 over a plus b minus b, a square minus b square. So 40 root 3 plus 1, this is 2, so we cancel. 20 root 3 plus 1 equal to H. Now if you go up to find the whole height of the tower, this is PQ is the height of the tower, this entire PQ. And if you see there, PQ is equal to PL plus QL, right? So height PQ of the tower is PL plus QL. Now PL is 40, QL is 20 root 3 plus 1. This is what we just found here. I'll just write it in the same color. We've just now found 20 root 3 plus 1. So we open the bracket, 40 plus 20 root 3 plus 20. So 40 plus 20 is 60 plus 20 root 3. This is PQ, the height of the tower. Next we have to find XQ. Now this is XQ, so we'll use Pythagoras theorem to find XQ. So we can write PQ square plus PX square equal to XQ square. Now PQ we already found is 60 plus 20 root 3 the whole square. Now PX is X, and we also found that X equal to H. We know X is equal to H, and the H we already found is, here we found H, so this is 20 root 3 plus 1 the whole square. This equal to QX square. We could do it yet in another manner. So in this triangle, we know angle 60, and what is sine 60? Sine 60 is perpendicular over hypotenuse. Sine 60 is root 3 by 2. This is a perpendicular and here is a hypotenuse. So the perpendicular we already found out, and we added up, and it was 60 plus 20 root 3. We found that PQ over hypotenuse H. So the H hypotenuse, which is in this case XQ, we'll just write XQ here, will be 60 plus 20 root 3 over 2 over root 3. If you rationalize this, you get 60 plus 20 root 3 2 over root 3 into root 3 into root 3. So XQ equal to 60 plus 20 root 3 over 2 root 3 over 3. And you can leave your answer at this point. or you could open the bracket and simplify. A boy standing on a horizontal plane finds a bird flying at a distance of 100 meters from him at an angle of elevation 30 degrees. So let's draw that. So the boy is standing, there is a horizontal plane they said, and the boy is standing here on the horizontal plane and he is watching a bird at a distance of 100 meters. So at an angle of elevation of 30 degrees. So here is watching up here. This is the angle of elevation at 30, and here is a bird. So this is the bird. See, this point is B and the boy is at A. One part done. Now the next part. A girl is standing on the roof of a 20-meter high building. So here is a building 20, which is 20 meter, and the girl is standing at the top of this here at the roof, and this was ED. Finds that the angle of elevation of the same bird is 45. So this girl is also looking at that same bird here, and now here the angle of elevation, this is the angle of elevation, is 45. Both the boy and the girl are the opposite sides of the bird. Find the distance of the bird from the girl. So this is our question. To find, this is our question. This is the distance of the girl from the boy, from the bird. Here, this is 100 meter. So we'll join this up here. And this is, we put it as C, this is F, right? And we need to find our B, E. So here's the figure. This is the boy at A. We have the bird at B. Then this was the house. ED is the house. And the girl is on the top of the house here watching the bird. Now let us first start with one of the triangles, and we're going to start with triangle ABC. So in triangle ABC, the theta you know is 30, which is given to us. Here is the perpendicular and this is the base. So perpendicular is BC and the base is AC. So we took the perpendicular as H. Here they've taken it as H, and this they've taken as X. So this is H and this is X. So we do 10 theta perpendicular over base, that is 10 of 30 perpendicular H base X, and we know our 10 30 is 1 by root 3. So 1 by root 3 is H over X. So the H will be X over root 3. If you see the sum, I think I've gone wrong. I must not start with 10 theta. Why mustn't I start with 10 theta? Because if you notice, what is given to me, the hypotenuse is given to me, isn't it? Who was the hypotenuse here? This is the hypotenuse. So hypotenuse and base I have. So I need to erase this up. This was not right. So let me do that again. So hypotenuse was BA, which is 100 meter. And I'm going to take perpendicular, not even base, because I don't need the base. I'm going to take perpendicular. So, and the perpendicular is BC, which I don't know. So I start with 10 theta, not 10, hypotenuse and perpendicular sine, perpendicular over hypotenuse. So we have sine of 30 will be BC over hypotenuse 100. Sine of 30 we know is 1 by 2 is BC over 100. So your BC comes as 50. So this is one thing, BC is 50. So now we have found this entire thing BC as 50. Now what would be BF? If you see BF will be BC minus this 20 minus FC. So BF will be BC minus FC, which is 50 minus 20, and BF now is 30. Now I'm going to take up the other triangle here, this triangle. That is triangle BFE. And remember, this is my question. I have to find the distance between the bird and the girl. So the theta 45. Here I know the perpendicular. Perpendicular is BF, which I found is 30. And I need to find my hypotenuse. Hypotenuse is BE. Now perpendicular hypotenuse, I need to use sine theta. Sine theta perpendicular over hypotenuse, and that is sine of 45 equal to perpendicular is 30 hypotenuse BE. 1 equal to 30 over BE. So BE equal to 30. So this is the distance between the girl and the bird is 30 meter. The angle of elevation of a jet fighter from a point A on the ground is 60 degrees. After a flight of 15 seconds, the angle of elevation changes to 30 degrees. If the jet is flying at a speed of 720 km per hour, find the constant height. So here is the ground. This is the ground. And from a point on the ground, we are watching a jet fighter and making an angle of 60 degrees. So angle of elevation, this is the line of sight. Here is the jet fighter at this point, and this angle here, at first angle here, is 60 degrees. Then the jet fighter moves away like this to another point. So definitely the angle of elevation also is going to change. After 15 seconds, the angle of elevation becomes 30. So now here, this is 30. This is the angle. It changes to 30. And remember, the time taken for the fighter to go through the distance is 15 seconds. So the time is 15 seconds. And is traveling at a speed of 720 km per hour. What we need to find is its height at which the jet fighter is flying. So this is PQ here, and say it is BC. Now here the speed and time is given to us. The time is given as 15 seconds and the speed is given as 720. Here look at this, 720 km per hour. Now the 720 km per hour we always make meter per second. So 720 into 5 by 18 to make it meter per second. And on working that, you get 200 meter per second. So again I got time and speed. If I have time and speed, I can always find distance. Distance equal to speed into time. That is, speed is 200 and time is 15. So I will get now 3000 meter. Now the distance traveled is 3000 meter, but which distance are they referring to? Here we have seen it is this distance, it is PB. This distance it has taken 15 minutes to move at a speed of 720 km per hour. So 3000 is this, PB is 3000. Remember, if PB is 3000, QC will also be 3000. This QC will also be 3000 because they are equal. And then we carry on the sum the same way. We will take this as height. The height, this is the height at which the jet fighter is flying. So we'll just mark what we found out. We found out this is 3000 meters. You know how we found out speed into time. This is also 3000 meter. We're not going to take this as h. We're going to take this as here h and this also as h. Now, as all other sums, we are first going to take the triangle with 60 degrees. This is the triangle with 60 degrees, and that triangle is APQ. Theta 60, we are going to mark its perpendicular and its base. The perpendicular we saw is PQ, and this is the base here. So PQ perpendicular, we will take it as h, and AQ is the base, which we will take as, say, this is the base, we'll take it as y, it's given here, y. So we start with 10 theta perpendicular over base. So we have 10 of 60 perpendicular PQ base AQ. 10, 60 is root 3 h over y. So h equal to root 3y. You know, my whole strategy in this sum is to equate for h. Now we'll take up the other triangle, and the other triangle is of 30 degrees. This is the other triangle. So here is my next triangle, the green one. And then this triangle, in triangle BAC, here also we'll find h, and I will equate for h. So here theta is 30. This is the perpendicular. The perpendicular is BC, which is h, and the base is AC, which is y plus 3000. This entire thing is a base here. So again we do 10 theta perpendicular over base. So we have 10 of 30 perpendicular BC base AC. 10 30 y 1 by root 3 BCH y plus 3000. So cross multiply y plus 3000 over root 3 equal to h. So I have found out h here in this, say, equation 1, and I found out h here, and I will now equate for h. I will write h equal to h. So here are the values of h. So I'll write h equal to h. So root 3y equal to y plus 3000 over root 3. Cross multiply into root 3 y plus 3000. So 3y equal to y plus 3000. Y, that is 2y, equal to 3000. And your y equal to 1500. Now remember, our question is to find the height, and our h equal to root 3y. So root 3 and our y we found out as 1500. This is wrong here. Yeah. So our h is 1500 root 3 meters. This is the height of the aeroplane. Let's go over the sum again. How do we go about this? Is, you know, you got to first identify two triangles. To identify the two triangles, you know the angle. Now here one angle was 60, so you got to take a triangle where there is 60, and that is PQ, APQ. Then the other one is where there is 30, and for 30 the triangle is here. This is a triangle, and in both these triangles you notice that there is one thing common or equal, sometimes common, sometimes equal. So PQ equal to BC. So in your yellow triangle, that is triangle PAQ, you find your BC, find your PQ, and then you take the other triangle BAC, and here also find your BC, and then you equate both, because PQ equal to BC, PQ equal to BC. And to find PQ here, in the first case you will use 1060. It will be base over PQ over AQ. You will find this, and on the other side you will have 1030, and also perpendicular over base BC over AC, and you will find your BC and you will equate it.